In the video of covalent bond, we saw how atoms can share electrons, form covalent bonds and stick together. Now in this video, let's look at some more and different examples. How atoms of different elements like hydrogen and oxygen, they can form covalent bond and stick together. And we will also see how to draw electron dot structure of these molecules, these heteroatomic molecules. So let's take the example of water. See, water is H2O, meaning over here, one atom of oxygen is sharing its electrons with two atoms of hydrogen. And yes, there are only covalent bonds between oxygen and hydrogen in this molecule. And all the atoms in this molecule have their octet or duplet complete. So let's try to draw their electron dot structure and see how these atoms share electrons and become stable. So let's start with oxygen. So oxygen's atomic number is 8. That means in a neutral atom of oxygen, there are going to be 8 electrons going around it. And its electronic configuration, this will be 2, 6. Okay? That means there are 6 electrons in the outermost shell of oxygen. Let me try to draw it. So oxygen, 6 electrons around it. I'm going to represent it with cross, the electrons with cross. 1, 2, 3, 4, 5, 6. Okay? And by the way, we only draw the outermost electrons because in a chemical reaction, only the outermost electrons of an atom participate. Okay? So no need to draw the inner electrons. Now let's come to hydrogen. See, hydrogen's atomic number is 1. That means it has got only one electron in its outermost shell. So its electron dot structure is going to be like this, H with one dot. I'm using here dot to represent the electron of hydrogen. Okay? You can use cross or dot interchangeably. Doesn't matter. Since there are 2 hydrogen, so I'm gonna show 2 hydrogens over here. Okay, now see, they both are going to share electrons and become more stable, have covalent bond between them. Now, how does that happen? Can you pause the video and try this by yourself first? Now, if you have tried it, let's see. So see, we know that every atom wants to become more stable, just like noble gases. And we have seen that noble gases are stable because most of them have 8 electrons in their outermost shell. So over here, oxygen will also want to have 8 electrons, a complete octet. It currently has only 6 electrons. That means it needs 2 more, okay? Now, to get 2 electrons by sharing, it will have to share 2 electrons, right? So oxygen can share 2 electrons of its own. Now let's come to hydrogen. So see, hydrogen needs only 2 electrons to become stable. Just like the noble gas helium, it needs to have a complete duplet. Now it currently has 1 electron already. So it needs 1 more. Now to gain 1 electron, it needs to share 1 more electron. And over here it can share 1 electron with oxygen. So let's do that. Let's make hydrogen and oxygen share 1 electron with each other. Okay? So to denote sharing, let me draw the circle. So here this denotes that hydrogen and oxygen, they are sharing their 1 electron with each other. So if you just focus on hydrogen, see, its duplet is complete now. See, these 2 electrons that are shared, they are not part of hydrogen or oxygen. They are actually going around both of them. You can imagine them as going around both of them. Both these atoms experience these 2 electrons. So over here, since hydrogen is experiencing these 2 electrons, its duplet will be complete and it will be stable and happy. Let's do the same thing with this hydrogen. So actually, let me erase this and redraw it here. Let me change the color. Yes, hydrogen. Over here, hydrogen will share 1 electron with 1 electron of oxygen. It cannot share 1 electron with 2 electrons of oxygen. No, in covalent bond, there is mutual sharing that happens. Both the elements, they share equal number of electrons with each other. So let me close the circle. And similarly, this is oxygen's sharing. Okay, now same thing is happening over here. These 2 electrons are shared between both of them. They will be both of these atoms will be experiencing these 2 electrons going around them. So now hydrogen experiences 2 electrons around it. Its duplet is complete and it's stable. Let's look at oxygen. See, oxygen has these 4 electrons completely to itself. But now these 2 electrons, these 2 shared electrons are also going around oxygen and these hydrogen atoms. So this oxygen atom experiences 4 plus 4, 8 electrons around itself. So its octet is complete and it's stable, it's happy. So this is how a stable molecule of water exists in nature, by sharing of electron. It shares one electron with one hydrogen atoms. Now one last thing. If we had to draw the structure again and again, it's going to be very tedious. I mean, drawing these circles and showing these overlaps, that's going to be a tedious task, right? So we can simplify this. What we can do is get rid of the circles, and to show that, hey, a pair of electrons are being shared, meaning there is a covalent bond, we can replace these electrons with a single dash. One single dash to represent one covalent bond or one pair of shared electrons. Similarly over here, one pair is being shared, so we can replace this with a single dash. So a simpler structure could be something like this. We have oxygen, we have two hydrogens, and we have a pair of electron between them, shared between them, meaning one single covalent bond. So one single dash. Similarly, one single dash over here. And oxygen has 4 electrons that are not participating in sharing. So I can draw these 4 over here. Well, you know what? Even to make it more simple, we can even get rid of these 4 crosses and just say that this is our structure. O, single covalent, and H and H. This is our structure of water. Okay. Now let's look at one more example. This time I have a molecule of carbon dioxide. Here one atom of carbon shares electrons with 2 atoms of oxygen. And yes, there are only covalent bonds in this molecule, and all the atoms have their octet complete. So why don't you pause the video first and try to draw the electron dot structure of this molecule by yourself. If you have tried it, let's see. So I know that carbon, it has 6 electrons going around it. So its electronic configuration is going to be 2, 4. Let's draw the electron dot structure of carbon. So there are 4 electrons in its outermost shell. 1, 2, 3, 4. Similarly, oxygen, it will have 8 electrons going around it. Its electronic configuration is 2, 6. That means 6 electrons in its outermost shell. So here is my oxygen. 1, 2, 3, 4, 5, 6 electrons. One more oxygen. 1, 2, 3, 4, 5, 6. Okay. Now let's look at carbon. See, carbon would like to become more stable, have 8 electrons in its outermost shell. It currently only has 4. Okay. That means it needs 4 more electrons. And to get 4 more, it will need to share 4 electrons. So carbon is going to share all of its electrons. Whereas if we talk about oxygen, it already has 6 electrons. It needs 2 more to complete its octet. Now to get 2 more, it needs to share 2 electrons. So oxygen is going to share 2 electrons with 2 of the electrons of carbon. Something like this. Similarly, this oxygen will share 2 of its electrons with 2 of carbons. And now carbon, with this oxygen, it will share 2 of its electrons. So something like this. And with this oxygen, it will share again 2 of its electrons. Yes. Now if you look at the octet of oxygen, it had 6 electrons of its own, and now 2 electrons from the carbon are also being shared. So over here it experiences 8 electrons around itself. Its octet is complete. Similarly, this oxygen's octet is also complete. Now if we focus on carbon, it had 4 electrons of its own, and now it is experiencing 4 more from these 2 oxygen atoms. So 8 electrons. So its octet is also complete. So this is how the molecule of carbon dioxide exists in nature. By the way, if I have to represent this in simple notation, then I'll replace a pair of electron with a single dash, a pair of shared electrons with a single dash, something like this. And I can draw it separately to give you more clear picture. This is carbon. Here we have oxygen, and we have 2 double bonds with this oxygen and 2 double bonds with this oxygen. So over here, the atom of carbon and oxygen, they have a double covalent bond between them. Similarly over here, they have a double covalent bond between them. This is how carbon dioxide is different from water. Carbon dioxide has double covalent bond. Now let's summarize the video. In this video, we saw how atoms of different elements share electron and form covalent bonds. We also saw how to draw their electron dot structure and its simplified version. Now the principle remains exactly the same. Every atom will want to become more stable, will want to have a complete octet or a complete duplet. Now, if the atom needs one electron, then it will share one electron. If it needs two electrons, then it will share two electrons, and so on and so forth.